In this video, we're going to talk about solving absolute value equations and inequalities. And so our learning targets are being able to solve an absolute value equation, but as also solving an absolute value inequality and writing the solution in interval notation, which we learned about in our last lesson. So let's solve the following equation. The equations themselves are probably some of the easier ones to do, but they still have a few steps. And on my front page here, I do have this two-way arrow, which is very fitting because this will break into two equations. So let's get this absolute value by itself first. So we're going to ignore this 3x minus 5 and get rid of the 7 and the 2 to start with. So we're going to subtract the 7 and then divide by 2. I'm going to write 3x minus 5, and keep that in the absolute value here, is equal to 14. So subtracting the 7 takes us to 28, and divide by 2 is 14. Remember, an absolute value denotes the distance from 0. So we're saying this 3x minus 5 has a distance from 0 of 14. That could be 14 above or 14 below. We don't know that. And so that's where this breaks into two equations, which means we'll be solving by saying, okay, it could be 14 above, so at positive 14, but it could also be at 14 below or negative 14. So we're going to solve both of these and we will have two solutions. So add 5 takes us to 19, divide by 3 gives us 19 thirds. Add 5 here takes us to negative 9, and divide by 3 is negative 3. And then we'd go through and actually check our solutions because sometimes we could have extraneous solutions. So let's type it, let's do 19 thirds first. So 19 minus 5 is 14, absolute value that's 14, times 2 is 28, plus 7 is 35. So this one checks out. Negative 3, so 3 times negative 3 is negative 9, minus 5 is negative 14. The absolute value of that is a positive 14, times 2 is 28, plus 7 is 35. So both of these check out, which means both of these are solutions. And those would be our two answers, and that's how you'd write them. What about inequalities? Those are a little bit different. The idea of solving them is exactly the same though. So we'll get the absolute value part by itself to start with. So we'll have 8x plus 7, still in our absolute value, is greater than or equal to 12 because we added that 10. So once again, this is saying this distance is greater than 12. That means that that point on our timeline or our number line would be either 8x plus 7 is greater than or equal to 12, or 8x plus 7 is less than or equal to negative 12, because that means the distance would be greater than 12 in both cases. One's above, one's below. So let's go through and solve this. Subtract our 7, so we get negative 19. So x is less than or equal to negative 19 over 8. Now about this side, subtract our 7, so 8x is greater than or equal to 5. Divide by 8, x is greater than or equal to 5/8. So let's put some things on a number line here. So here's our 0. 5/8 is somewhere to the right. Negative 19/8 is somewhere over here to the left. Remember our negative infinity and positive infinity. What we're gearing up for here is interval notation. So at negative 19/8, so I can equal this, and then x is less than or equal to. So my arrow goes this way. At 5/8, x is greater than. So I'm going to still greater than or equal to. So I still have a closed-in circle, but now we're greater than, which means we're heading this way. So our interval notation is going to have two parts because we have two parts to our graph. So for interval notation, we're going to have x is an element of negative infinity to negative 19/8. So parentheses on our infinities, and since it can equal this, we have a bracket. Or, so that's our u, or it could be 5/8, including 5/8, so it's a bracket, to infinity. And that is our interval notation, that is our solution. So Hopefully you still remember how to do interval notation, but the inequalities and the absolute values here just have a little bit. So make sure with the inequality, it's kind of a big deal. The one that stays the same with our positive stays here, like greater than, matches our signs. But when you flip the negative, remember, just like when we multiply or divide by a negative, we have to flip the inequality. Sometimes you may have to flip them back. It just depends on what the actual problem is.